Hello, everyone, and welcome to this another look at 2D twin stick top down shooter. My name is Kasanis. Guys, in the last episode, we explored Unity's new input system. We really concentrated on Unity's new input system. We set up a really simple action map with a couple of actions that Unity provided for us, and we did some really impractical things with it. We changed the color of a sphere. In this episode, we're going to get our character moving and we're going to get our character aiming utilizing the thumbsticks. All right, everyone, let's get started. Okay, so I've got a brand new scene here. We're going to start fresh. I've gotten rid of the circle we were using in the past, and we're going to start fresh here by creating something that's going to be a stand in character. It's not going to be the character that we use ultimately. I don't really know what I'm going to do yet. I don't really know. My students are telling me one thing. They kind of want a fantasy theme, and I'm thinking maybe a kind of a sci-fi theme. I'm really kind of torn between the two. For what we're doing here, I think the sci-fi theme might be a little bit easier to demonstrate. We'll see. Anyway, for now, guys, we're going to build ourselves a really simple hierarchy, and that hierarchy is going to be used later on when we actually want to add in our character art and all that kind of stuff. But we're going to build an appropriate hierarchy right now for our characters. We already know a couple of things. First of all, I've got rid of everything else, a brand new scene, like I said. The only thing I kept is our action map. We're going to use this one. This is the one that Unity provided for us, and it does the things that we want to do for now. If we take a look, we've got ourselves a move action. That move action is associated with the left thumbstick. Awesome. That's how we're going to move. If we take a look at the look action is associated with the right thumbstick, and that is going to be how we aim. So let's do one thing at a time. Let's start off right away by actually going through and creating the hierarchy that we're going to need to be able to build up this character. That hierarchy is going to start with an empty game object. So I'm going to go here, game object, and say create empty. And I'm going to zero it out first of all. So let's make sure it's zeroed out. Let's reset this so it's at the origin. And I'm just going to change this name to, I'm going to call it player base. Let's just call it player base for now. It doesn't really matter what you call it. As long as you're staying organized and you know what you've called things, you should be fine. I follow along with YouTube videos sometimes if I'm learning something new. And sometimes I name things differently than the YouTuber is. And then I'm like, what the heck was that? And I've forgotten afterwards. So you're welcome to use my names. I'm not even thinking about my names right now, in all honesty. You should probably have some really good names, or maybe I should have taken some time and thought about my names, but I haven't. So player base is what we're going to call this particular thing. And we're going to use our player base as kind of like a holder for a lot of the different things we're doing. We don't want to add any kind of art to our player base. We want our art to be separate, and that way we can change it out without actually having an effect on the other parts of the hierarchy. So for now, our player base, we're going to add a couple of things to it. We know that we're going to need we know we're going to need a player input. So let's add that right now because I've already got it up here. So I'm going to add in my player input. We already know we're going to need this. This is how our player is going to be controlled and how we're going to associate it with our existing action map. So if we come in right here at the top, it says actions none, we have no action map. Click on the little circle thingy and choose the action map that you created before. This is automatically going to associate it with the actions that we have built, which is great. We'll talk about the behaviors in a minute. Right now we have send messages. And send messages means we're only sending the information to the hierarchy, this hierarchy level. And we're going to change things in the future. But for now, I think we can. Let's just change it right away. I think in the future, we're probably going to use broadcast message. I'm going to stick with those same ideas, either send message or broadcast message. I'm going to stick with those same ideas because it is what I've taught in class, what my students are used to right now. I'm going to change it to broadcast message right now. That'll give us opportunity later on to actually communicate with lower parts of this hierarchy. I don't yeah, I don't think we're going to need it right now. We're not going to actually need it to be able to broadcast right now, but let's just send it right away. It's fine. It might be a mistake, but let's see. Let's zoom in here a bit. So there's my circle. I've got my circle in place. It's got the player input. I'm going to add in here as well a physics component because I actually need a rigid body of some kind. A rigid body 2D in this particular case because we are working with 2D. So I'm going to add a rigid body 2D, and we can make adjustments to this a little bit later on. We're going to want to adjust it depending on the type of movement that we actually add. For now, I am going to do a couple of things. I'm going to go to my constraints, and I'm going to make sure that I have frozen the rotation in the Z. In my particular case, I don't want this object to rotate. That may change for you depending on the type of game you are making. I want my character to move. When my character moves, I don't want this actual object to rotate in any way. I want it to remain in the orientation that I've set it. You may decide later on that you want your object to be pointed in a specific direction as you move around. So it's kind of like, if you're making a spaceship and that spaceship had its front facing in a particular direction as you moved, you may wish to adjust this and allow for rotations to occur. Allowing these rotations to occur, though, can have some issues. It can cause rotations to occur when you're not expecting it. So if there's a interaction with a physics object, these things bump together, your object can rotate. So I'm going to freeze my rotations to make sure that doesn't happen. I'm also going to set my gravity scale to 0. I don't want this particular object to be affected by gravity, but I do want it to be affected by other forces that are applied to it. Okay, so with those two things done, I've got myself the player base set up the way I currently need it. It doesn't actually do anything yet. If I hit play, nothing's going to move, nothing's going to change, but it's set up now to allow me to use this particular object to hold all of my physics stuff, all of my scripts that I'm going to create in the future. What I like to do is I like to separate my art from the actual player base here. So what I'm going to do is I'm going to click on this. I'm going to say game object. So when I say click on this, I clicked on the player base. I'm going to go to game object and I'm going to say create empty child. And you can call this whatever you want. This could be your player art, let's say. It's where I'm going to store any of the artwork that's associated with my character. That might have a hierarchy of its own as I put something in there. There might be a hierarchy of its own within there if I've got a rigged character, or if I have a character that has, stuff attached to it, it might have a hierarchy of its own. But for now, I'm going to use that as a placeholder where any of my art in the future will be attached. It is directly attached to the player base, so it'll move along with the base. I'm going to do the same thing with my aiming asset, and I might as well add that in right now. So what I'm going to do is I'm going to go to, again, player base. I'm going to say game object, and I'm going to say create empty child. In this particular instance, I'm going to create something that is going to rotate, and again, it's going to be independent of art. It's kind of like our player base, but let's call it our aim base. And we're going to be using this particular object to aim, to actually rotate and aim in the direction of the weapon that you're firing. Okay, and then from this as well, I will then add a new component, game object, create empty child, and that empty child I will call my aim art. You can call it weapon or whatever else you might want to call it, but it's the art that's going to be associated with the aiming of this object. So if I have a gun and I want it to rotate, my gun will be attached to the aim art, and I can swap it out really easy. In doing it like this, I have set myself up for success as far as things like inventory is concerned, swapping out images really easily without affecting anything else associated with this particular asset. Let's go ahead and add a little bit of art right now, just so we've got something. I'm going to go into, I create this, and you guys should consider the same thing. I always create myself a little folder that contains really basic objects. In this particular case, I've got a circle, a platform, really simple objects that I can toss in and make work in some way. I'm going to come up here and I'm going to actually add into my player art this circle. And the circle itself right now is just under player art, which is perfectly fine. And that circle is just going to act as the body of my character. Let's actually give it a color. Let's change it to like a green, maybe like that. Okay, just so we can see it. So I've got a circle in there for now that's going to act as my art just temporarily. I'm going to do the same thing with my aim art. I'm going to grab this arrow and I'll just drop it underneath the aim art. Remember to set up your art so that it is working appropriately in 2D, we have to remember our order and layer. Right now, my arrow is underneath my base. I can't see it. Maybe that's where you want it. Maybe you want to have it like peeking out like this or something. I don't know. If you want it on top, you're just going to change your order and layer. By default, it's going to be 0. By changing the order and layer so it's higher, it'll be rendered afterwards and rendered on top of what you've got there. So I can just move my asset like this. And what I'll do is I'll just keep it called arrow and I'll keep it called circle for now. This is my player art where I put my character, and this might be the weapon that I have associated with it. And I've just kind of moved it off to the side. This is not where I'm going to leave it. I'm going to actually change where this is when we move into aiming. We're going to ignore aiming for now, and we're going to kind of tackle the movement first. So we already know that we want to use our existing action map. So let's go over here, our action map. And we already know that for movement, we want to use our left stick. So let's take a look at the difference. Before we did some work with fire, it was the right trigger. If I click on fire over here, you can see it has an action type of button. Nothing else is associated with it. There's a difference when I take a look at move. Move has different action properties right here. We have an action type of value, and the action type itself is referencing when the function is called. So with a value set, there's a number of different settings here. We've got ourselves value, button, and pass through. Value means that whenever there is a change from default, so from the default state, whenever there's a change from the default state, the the function that we have associated with this action will be called. That's what it's basically telling us. So, for example, if I leave my stick, the stick is considered at 0 by default. All like nothing's been moved. There's no values coming in from there. If I move my thumb and values change, then because the action type of value, there will be a call to whatever functionality I have associated with this particular action. Below that, we have our control type, and our control type is vector 2. If we take a look here, we have a number of different options as far as what we are sending. This is basically what this is. The control type is what we are sending whenever we are moving around that thumbstick. With a thumbstick, we want the vector 2, we want the movement, we want the vector that's associated with the direction of movement. So that's what a vector is. It's going to point in a particular direction. It's going to have a magnitude and a direction associated with it. And we're probably going to dump the magnitude. We are going to dump the magnitude, but we're going to utilize the direction. So we want to set this up for a vector 2. If you were doing in 3D space, you'd want vector 3, etc., etc. I don't know if you can actually get you can get vector 3 data from the thumbstick, but I don't know how useful it is. It's just going to be 0, whatever the default value is for the third dimension. In this particular case, we want vector 2. Okay, so we've got a vector 2 and we have a value, so we have to know that as we actually start to create our scripts. So let's add ourselves a script that we're going to use for the control of all of our characters. I'm going to add it right here to my player base. So I'm going to come down here. I'm going to say add component. I'm going to head down a new script and let's give it a script name. Let's call this our player. Oops, I called it a capital L there. Our player control system. Terrible, terrible names. I need someone. Maybe I start using AI to generate good script names. That's so generic. It's so meaningless. Anyway, I'm going to use it because I'm pretty lazy. Player control system. Let's create and add our player control system. Let's go. It's creating it. Yay, super fun. I think I've dumped it into assets. I don't want it here. I'm just going to move it right away into my scripts folder. So I've got everything kind of in the same location. And let's double click to open it up right here. Let's double click and open it up. It's going to take a second. And it's going to open on the wrong screen, which is also awesome. Let's drag her over. Okay. So a couple things we know right away we have to do. We have to add in our using Unity engine dot input system semicolon. We want to use that library for sure, so we're going to add it right away. There's a couple things that we need to think about before we actually start moving on. And maybe I should have discussed this earlier before I opened up the script at all. There's a couple things you're going to want to do. You're going to want to think about how you want your particular character to move. There are a number of different options as far as movement is concerned. We can move our character around simply by adjusting the transform node's position. That's going to move our character through space. It's going to ignore physics as we move it around because it's teleporting to a new position each time. That works for some games. That might be what you want to do. I very rarely do it. I normally work within the physics engine and I either adjust the velocity or I apply a force to an existing rigid body. We've added our rigid body already to our player base. We know it's there. So we're going to use one of those two methods. Whichever method you decide to use is 100% up to you. There's no right way or wrong way to do it. You just have to understand the difference in the two. By applying a force to an object, we are allowing that object to ramp up over time. It's being affected by whatever gravitational forces are associated with it. So we can add a different force to make it, if there's an explosion, it can be bumped off somewhere else. We're applying a force to it, to the rigid body itself, and then that rigid body has additional functionality. Let me just move this out of the way for a second so you can see. Let's go back here to our player base. Let's take a look at our rigid body. We've got things like linear drag and our angular drag and all that gravity scale, all that kind of stuff is associated with the forces that are applied to this particular object. If you want your character, your player character, to be influenced by additional forces that are applied to it, then application of force as movement might be the way to go. If you're making kind of an arcadey style game and you want an instantaneous change in velocity of the character, then you will change the velocity of the rigid body. By adjusting the velocity of the rigid body, you are instantly changing the velocity to whatever you set it to. So if your character is currently not moving, it's got a 0 velocity, and you change your velocity to a value of 10 in the X, it'll instantly start moving at a speed of 10. If I am doing it with forces that I'm applying and I apply a force, then those forces are applied over time. I mean, they can be applied as an impulse, but those forces are applied over time. And as I'm applying the force, that object will increase in speed based on the linear drag I have associated with it and that kind of stuff. So, depending on how you want that character to move and how you want it to stop moving, because if I let go of the thumbstick and I have it set on velocity, I will instantly be going 0. If I let go of the thumbstick and I'm using applied forces, those forces still exist on that object and they have to dissipate based on the linear drag. So my character will slow down over time. This is a design decision. This is a game feel decision. This is what you want to decide before you move forward. If you haven't decided that, take a minute right now, figure that out, and I'm going to apply force for this one here. So I'll be doing application of force. Application of velocity will work in a very similar manner. Just the code itself might change a little bit. Oh, let me actually adjust this because you guys probably can't see this. Let's make it 200. It's huge. Okay, awesome. So let's take a look at this code now. Let's start actually getting this thing to work. We know a couple things. No matter what happens, this character is going to have a maximum speed. So let's, right up at the top, let's add in a float. We'll make it a public float, actually. We'll make it a public float so we can adjust it outside. There's other options besides public to protect it, but I'm not going to worry about that right now in this beginner tutorial. We'll just keep it as public. Let's make a public float, and let's call this public float base movement, maybe base speed. Let's call it base speed. All right, so this is going to be the base speed that our character can actually reach. All right, it's going to be a value that we don't want to go past. Uh, maybe later on we'll talk about like adding boosts to our character, so they have maybe a dash or something like that. And if we do, we want them to return back to this base speed. So we're going to set this up. We know we need that. We also know that we need a couple of other things. We know we need a direction that we're going for movement. We know we need a direction that is going to be the direction the player is moving based on the information we get from the stick itself. So let's add in here a vector 2. So we can get a vector 2, and let's just call this let's call it our move direction. All right, we'll call that our move direction. And again, like I said, that's going to be used for applying the direction of our character's movement. We need a couple of things here. We definitely need the rigid body because I have decided that I'm going to be using the rigid body to move this object around, and I'm going to apply forces. So let's make a rigid body 2D, and we'll just call it my RB. All right, and we have to find this right away. This object is being applied. It's going to be applied to the player base. So let's just use our myRB is equal to get component rigid body 2D perfect autofill right there. So it's going to be utilizing that rigid body. It's going to be finding the rigid body on the same hierarchical level as this script is located. Okay, so knowing all of that, we can start to now add in the code that we require in order to be able to accept the input. So just like in the last episode, we're going to go down here and we're going to add ourselves a function that is going to be used to capture the input from our action map. If you guys remember correctly, we went through when we added ourselves a public and void. It was a void, and again, we're going to use it as void. And we have to use the keyword on, and then in this case, we're going to use our on move. And it's going to autofill this. It always does. It makes me so mad. Please don't. Good. Okay. All right, there we go. And this time here, we're actually going to be utilizing some of the information that we get back from our on move. We're going to utilize the direction that it's supplying to us. So what we're going to add in here is the input value. So if you want to start typing input and look for input value, I should have maybe typed a little more. Input value. There we go. Input value, and you can give it some name. Let's just call it move value. That's fine. Move value. Okay, and let's add in our brackets. And at this point in time, we will capture that information. Now, we took a look at the move properties, and part of that was the fact that the move was supplying us with a vector 2. Well, we've already got our vector 2 at the top. We've already called that move direction. So let's set our move direction equal to, and what we're going to use is the move value dot, and we're going to use the get function, and we're going to get, this is actually set up wrong, sorry. We're actually going to use the move value, and we're going to use in our square brackets, we're going to look at this as a vector 2, okay? And then afterwards, we can add in our round brackets. This is going to return to us a value. I believe that this value is normalized already, but you know what I'm going to do just to make sure is I'm going to add in normalized. So I'm going to normalize. Delete slowly. Normalized. All right, I'm going to normalize this just to make sure that I'm getting a magnitude of no greater than 1. Like I'm getting a magnitude of 1. And that's going to allow me to then multiply my actual value by my what I call base speed. By my base speed later on, it's going to allow me to do that to have my character moving in a very particular manner. Okay, so there's a couple things that we want to do here. We're going to want to make sure that we are, because I've decided to do this with a force as opposed to velocity. If I was working with velocity here, and I could just read this value, I could multiply my vector times the base speed, and I could set my velocity equal to that vector, and my character would instantly be moving at that particular rate. I've decided to do it through force, and that's going to mean that I need to apply that force as long as I'm receiving the value from, as long as my player is holding the stick in a particular direction, I want to apply a force to a maximum level to make sure my character is moving at a particular rate. So there's two different ways you do it. Like I said, if I was using velocity, I could just write the code right here. But in this particular case, because I'm using forces, I'm going to have to maintain the idea that I'm applying that force. So what I'm going to do is I'm going to go back to the top for a second, and maybe I'll just add it right here. Maybe I'll add it below this so I keep everything together. I'm going to add a bool that I'm going to call moving, and the moving bool will tell me whether or not I'm actually moving. Let's actually set it equal to false for now. It's probably unnecessary, but let's just do it for simplicity's sake. What I'm going to do is I'm going to take a look at the magnitude in my onMove. I'm going to take a look at the magnitude of the vector 2. If my vector 2 that I get, if my move value is 0, then I'm not moving. That means that the stick has been returned to its original position and the player is no longer applying an input. However, if the magnitude is greater than 0, then I am moving and I want to do something. So let's just say in here if, and what we're going to take a look at is we're going to have to take a look at the absolute value. So we're going to use our mathf.abs to look at the absolute value of our vector 2, the magnitude of our vector 2. And what we're going to put in here in our brackets, we are going to put our move direction dot, and we're going to take a look at the magnitude. So as long as our magnitude is greater than 0, then our player is applying pressure to the stick. Okay, so, and that's exactly what I want to do. That's good, perfect. Moving equals true. Again, autocorrect or auto input here. Awesome AI, thank you. It doesn't always work, but it sometimes works. All right, so we're gonna set our moving to true. Otherwise, if our magnitude is equal to 0, so in the other case where it's equal to 0, we're gonna say moving is equal to false. Okay. So what do we do with this? What do we do this now? Well, we're going to have to do something within our update or our fixed update to make sure we're applying our forces over time. That means we're going to have to write a function. So we're going to write an additional function that is going to allow us to move our character. So let's add ourselves a new function. We'll call this thing, we'll make it a void function, and let's call it player movement. We'll call it player movement. All right, and it is going to take no, I don't actually need to take a value because we're already saving our move direction. So I'm not going to have any parameters. Let's do it like this, boom, boom, boom. And what we'll do is we'll take your rigid body. So we've already defined our rigid body, and we're going to use our add force. So in my particular case, like I said, we're going to use the add force. And what do I want to add for? What forces do I want to add? Well, I'm going to create myself a new vector 2. And this new vector 2 is going to be created around our movement, our move direction. All right, so I need my move direction.x. It's already been normalized, so this value is going to be small enough that I don't have to worry about anything. And I'm going to multiply my move.x times my base. I could have done this at the end if I want to, but I'll do it right here. Times my base speed. And we'll do the same thing with our y. So our y is identical. Our move direction.y, our base speed. We don't care about the z at all. And this is going to apply a force to that rigid body. Now we have to call this. So let's go up here, and I'm going to use my my fixed update. So let's create our void fixed update. That allows us to work within the within the physics engine and not work outside of it. So there won't be any kind of like hopefully won't be any kind of hopping or jiggling that occurs. It occurs. The fixed update occurs at a very particular rate. You can set the rate. I think it's 0.2 seconds or 0.02 seconds that it runs. There's a big difference between those two things, I know, but it runs at a very particular rate. You can set it. Whereas update will run every frame. You can set this up so it's frame independent and it'll be perfectly fine. But we're going to use our fixed update to make sure that we're remaining within there. So let's go in here and what do we want to do? If we are moving, then we want to call our, whatever I called it, I've already forgotten. We want to call our player movement. All right, player movement with nothing. Boom, we're going to call player movement. And that's it. This should actually get us moving. If as long as we are applying our pressure or applying our pressure to our stick, then this will actually get us moving. So let me file save this. All right, let's move it out of the way. We have to make a couple of quick adjustments to our our player base. So if we come in here to our rigid body and we have a mass of 1, let's just leave our mass for now. Let's set up our linear drag to 10, let's say. And we want to change our base speed, so let's change our base speed to 50. These are just numbers I'm guessing at, just so you guys know. You are going to adjust these values so that your game feels good to you. That's what we want to do. Okay, so let's go here to our scene. We can see our player here. We have everything in place. Got my fingers crossed. I'm going to pick up my controller. I'm going to drag it across my microphone so it makes a lot of extra noise. That's perfect. I've done that. Now I'm going to hit play. And with our fingers crossed, moving around, look at that. It's moving around. If I let go, I come to a slower stop. So that slow stop and that slow start is based on the linear drag I've given it and on the amount of force I'm applying. Okay, so that was pretty easy. There wasn't a lot of code there. Our aim is going to work very similarly, so let's get our character aiming as well. The real difference between the aim and the actual movement is the fact that we want our arrow, the arc we've got here, we want our arrow pointed in the direction we are aiming. And this is going to be used as visual feedback for our players so they know where they're aiming. And when they shoot, then they're going to shoot the things that are in that direction. So that's the real difference. Otherwise, we're doing a lot of the same similar stuff. Same similar. All right, let's take a look at our action map here. Let's take a look at our look. Our look is still value and still vector 2. So all that stuff we did before is going to apply to our aim as well. Let me drag our code back here. Okay. Let's add a couple of things in here. So again, we're going to need that vector 2, right? We know we're going to need that vector 2. It's going to be our look direction. So same way we used it before, this is going to be the direction that we were looking. The other thing we need, though, is the object that we're actually rotating. We've already set up our hierarchy to represent that object. It's our aim base. We're going to rotate our aim base, and we're going to rotate that aim base along the z-axis. The z-axis is the axis that's coming out of our screen. We're playing in the xy plane, and the z-axis is pointed outwards. So if we rotate our object around the z-axis, it's going to rotate within the xy plane, and it's going to aim our object in the direction we want it to aim. Awesome. That's exactly what we want to do. So we're going to need a reference to the transform of the aim base. So let's go in here and we'll make this into a public, and we'll make it into a public transform. And let's just call this our look transform, I guess. It's fine. Look transform. And we made it public, so we'll be able to just plug it right in. So with those two things there, once we fill those in as in the inspector, we're going to need to access the functionality in the same way we did previously. So let's just grab this. We'll use this as a base. We're not going to have to do a lot of this stuff actually because it doesn't work in exactly the same way. Let's change this to on look. So first of all, on look, and let's change this to look value. It might have been easier just to type this, but let's just do it. Look value. Let's change this to look. And let's change this to look. Maybe I should have done it. Looky. Normalize it again. That's great. Yep, and we're going to want to use this too. So let's get rid of this look. And we don't need this else though. So the difference, there's a couple of differences here. We don't need to do things over time. We're going to point in a particular direction, and we're going to looky direction. And we're going to continue to point in that direction until we point in another direction. And we're going to set this up as well so that it doesn't return to 0. So if you let go, just like when we let go of the stick, in the case of movement, when you let go of the stick and the stick returns to its default state of 0, the object itself no longer applies the force, and it stops moving. We're not going to do the same thing with the look. Instead, with the look, we're just going to read the stick, what direction it's facing, update it whenever there's movement within the stick. But if it returns to 0, we're not going to have it spring back to some default location. It'll continue pointing in the direction that we want to go. That's how we're going to set it up for now. Maybe we don't want to keep it that way, but that's how we're going to set it up for now. So as long as our look direction has a magnitude greater than 0, we want to do something. And that something we want to do is rotate our transform along its x-axis, the up axis in this particular case. We want to rotate our transform along its up in the direction of the look direction. Okay, so let's say look, and we want the look transform. We've already got a reference to that above, but we want the up vector. And we're going to set our up vector, exactly as it says here, equal to our look direction. And that's all we should really have to do. I'm going to file save this once again. File save all, and let's move this out of the way. Okay, we have to make a couple of quick adjustments here. So I'm going to go to my player base. I'm going to scrub down, and I'm going to change my look transform to my, oh, I just want to drag it in actually. I'm going to grab my aim base. I'm going to drop it off right here. So I'm using this as my look transform. If I hit play now, everything should work. Fingers crossed. Can I move? I can still move, which is awesome. Now, if I utilize my right thumbstick, I can now point. Now, it's not pointing in the direction I want it to point. Right now, I've got my thumbstick dragged straight down, and it is pointing to the right. So I know this has not been set up properly. So let's stop this and make a couple of quick adjustments. And this is where our aim art comes into play. In this particular case, my aim art is 90 degrees off. So I can simply make an adjustment to, which value is it? Is my Z? It is my Z. I should have known that because I just told you that. Let's make this 90, negative 90. Now when I hit play, with my art adjusted, I didn't adjust the actual base itself. Now, if I'm pointing upwards, my arrow is pointing upwards. If I'm pointing to the left, I'm pointing left. If I'm pointing right, look at that. It works exactly like I want. I can move. I can aim independently. Awesome. And that's exactly what we wanted to achieve for this particular video. So that's it, guys. That's how easy that is. We got our character up and moving. We built ourselves a simple hierarchy. Our character can now move with the left thumbstick. It can aim with the right thumbstick. I can't wait to see what you guys are building out there. All right. Thumbs up, thumbs down, comments down below. And if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.